Hi, I'm James Kao, head of AIOps APM Product Management with the Enterprise Software Division here at Broadcom. Today, I'm going to talk about how we took our AIOps monitoring platform from a monolithic architecture to a modern microservices architecture. If you think about a traditional monolithic architecture, you would think of having a couple of big servers being the heart of the system, right? And these servers here would be in some kind of replicated setup, and they'd be load balanced to take in input from users, or in our case, we're taking input from the remote monitoring telemetry that we have. Within each of these individual servers, we'd have the totality of all of the functionality within our application. So for instance, all of our metric capability would be in here, trace management capability would be in here, user interface and all of our storage would all be in here. And each one of these would have all of the functionality. And so this guy would have all of these things here, and so on and so forth for each of the individual servers. These types of monolithic servers oftentimes may have, as we do in our case, some type of manager of managers on top of them. And you can get 1, 2, 3, 4. Eventually, you can't have an infinite number of these. Now, what are the challenges with this architecture? Well, we like this architecture to start with because if I'm standing up a single server, right, that makes things easy. But as I grow, as I need to bring this architecture into a software as a service scenario, where I have to offer SaaS as a service, one of my first big problems is the data coming in from the wild may be bursty. Suddenly, I might get a doubling or tripling of data coming in, and it's not that easy to scale out this monolithic architecture that quickly. Plus, I may need to add in some additional new capabilities, perhaps big new functionality like AIOps, a data lake, data storage, and suddenly I have other technologies like maybe Elasticsearch or Spark or Kafka, and if I stick these into these servers and have to replicate them in these existing servers, things very, very quickly get complicated. What does this look like in a microservices world? Well, let's take a look. In a microservices world, we have to break down our capabilities, right? And in our different microservice containers, we really want these focused on one particular capability. And so let's take our metrics, right? We break that down into a single microservice. Then we take our trace processing. We put that into a single microservice. Things like alert management. That would go into a single microservice. Data and telemetry would come into a central point that we would call an ingress, and then get distributed out to the places that need that data. When I need to scale up, the individual microservices each have a very narrow set of concerns. And so when my metric stores start to get loaded, start to get full, they know, and they can scale themselves out individually. If I have a system that's doing a lot of complex alert processing, these systems can then scale themselves out as well, and they can do so in a contained and in a centrally managed way. Controlling all of this within a Kubernetes backplane allows us to control this system of microservices centrally. So rather than in a kind of a traditional setup, when I was doing management, I might have to SSH directly into these different boxes. Now, my total cost of ownership can go down by a lot because I can operate here from a Kubernetes console and a dedicated cluster management console built on top of cluster management APIs. So now there's a console that then controls the system that my operators would connect to directly. This also enables us to add bold new functionality into our system more easily. For example, let's say I need to add a data science layer. Maybe I need components like Apache Spark or other complicated mathematical and AI or machine learning processing components. I can add that in, and it can then access the other microservice functionality that it needs, and I don't need to deploy this all over and spread it all throughout our cluster. This also means that if I then start to unify in other management domains, right? Let's say I want to start bringing in network data. I can also incorporate that very easily into microservices without making the monolithic architecture complicated or too big or creating too many different kinds of servers. And all of these get that scaling benefit. Net benefit to our customer now is ease of scaling, lower total cost of ownership, and the ability to benefit from greater feature delivery agility.